We just learnt about the 4 statistics we use to summarize a confusion matrix as it relates to a given class. However, if we just look at these numbers by themselves, they don't always give us the complete picture. For the rows class, for instance, we might have hundreds of false positives. But is this good or is this bad? Well, if we just look at the number itself and say we got hundreds of them, that probably sounds bad. But what if we just had lots of test samples to start off with? So we may have had hundreds of false positives, but we might have had thousands of true positives. So one way to better help us understand the numbers is to convert these numbers into rates, which are basically fractions, and then we can use the rates to give us a better picture of what's going on. So we're going to look at 4 different rates. The first one is the true positive rate, which is also called the sensitivity. So the sensitivity, which is the true positive rate, is equal to the count of true positives divided by the sum of the true positives plus the false negatives. And this is giving us an indication of the probability that an actual class will be classified as that class. So for example, the sensitivity would measure the probability that an image of a rose will be classified as a rose, or for instance, the probability that if you had a virus, a classifier that is built to detect the virus will show you that you have that virus. And generally, the higher the sensitivity, the better the classifier is for that class that you're measuring. The next rate we're going to look at is specificity, which is the true negative rate. So the specificity is equal to the true negative rate, which is the count of true negatives divided by the total of true negatives plus false positives. So this is indicating the probability that something that is not the class will not be classified as that class. So examples would be the probability that an image of a tulip will not be classified as a rose, or in the medical case, the probability that if you don't have the virus, your classifier will not show that you have that virus. And in general, the higher the specificity, the better the classifier is for that class that you're measuring. The third rate we're going to look at is called the type 1 error, or the false positive rate. And so the type 1 error is equal to the false positive rate, which is equal to the count of false positives divided by the sum of false positives plus true negatives. So this is indicating the probability that something that is not the class is classified as that class. So for example, the probability that an image of a daisy will be classified as a rose would be part of the false positive rate. Or the probability that if you don't have a virus, the test will show that you have that virus. So you can see that the lower the false positive rate is, the better the classifier is for this class. So a high false positive rate is not good. And the last type of rate we're looking at is the type 2 error, which is the false negative rate. And the type 2 error is equal to the false negative rate, which is equal to the count of false negatives divided by false negatives plus true positives. And this is showing us the probability that an actual class will not be classified as that class. So the probability that an image of a rose is classified as a tulip would be an example of something that would fall inside the false negative rate. And in the medical case, the probability that if you have a virus, the test will not show that you have that virus. And so you can see the lower the false positive rate, the better the classifier is for this class. And so a high false positive rate is not good either. Here's a summary of all the statistics that we've covered so far. And so with all of these different numbers, how do we put them together and determine whether the classifier that we're testing is good enough for our purposes? So there isn't one answer. It all depends on how we're planning to use our classifier, and that will inform which statistic and which rate we are going to emphasize and prioritize the most when we are measuring our classifier. So a couple examples here to illustrate. If we were going to design and use a classifier to diagnose a medical condition, we might want to minimize the type 2 error or the false negative rate. That is, we don't want our classifier to indicate something is safe when it is actually dangerous. But if our classifier might be used for helping with identifying guilty criminals in criminal cases, a false positive might be more harmful. So we want to minimize the type 1 false positive rate, because a false positive in the criminal case might identify someone as guilty when they are actually innocent. And finally, there is a direct relationship between sensitivity and the error rates. Having a higher sensitivity will reduce type 2 errors. That is, it will lower the false negative rates, and having a higher specificity will reduce type 1 errors. That is, it will lower false positive rates.